Hello and welcome back to another stream of Sig Does Python Programming. Yes, it was. Let me get something playing in the background here without being like super loud, hopefully. I said not being super loud. Alright. I don't know why I opened this. So I think I told you already, I do use this site for programming like practice because it's pretty good. It gives you lots of different scenarios to work with. So in my first video I covered these 3 tasks, so I'll probably do the next 3 or so today. And just kind of walk through my thinking process as I go through them. So, here we go. Given an array of integers, find the pair of adjacent elements that has the largest product and return that product. So, that means every 2 numbers we need to compare and figure out which set has the largest amount. Or the largest product. So by multiplying them. So this deals with some arrays, which we haven't dealt with yet. So arrays in most programming languages are just numbers or objects in individual slots that you can access by specifying an index. So let's start by looking at this. Python probably has the ability to output the arrays. Yes, definitely do. And should have the ability to access each individual array element as well. Excellent. So, array elements start at 0 and go up to whatever the max is. Just like strings. So, a string was literally just an array of letters. So this is just an array of numbers, dealing with the same type of idea. Yep. It starts at slot 0 and then goes up to, in this case, this is slot number 5. If there are 6 elements, 5 would be the last slot, 0 would be the first. So we're going to be writing some pseudocode, because, as you know, we're probably going to need a loop. We don't know the number of times this happens, so we definitely are going to need a loop to complete this. So we need to figure out the number of times we have to do calculations. In this case, it would be the number of elements minus 1. If we have 6 elements, we're going to check 5 different sets of numbers. So, using this as the example here. We need to check this number and this number. Then this number and this number, and so on and so forth. That is 5 checks total. So, loop count is going to be length of array minus 1. Would this multiply each index and then store it in the end, compare the final results to each other? That is one way to do it, but most of the time if you're storing the largest of something, you only need a max variable. So we're going to have a max variable. And it's going to store what the highest number we've found so far. Oh, wait, we need the pair of adjacent elements. So we need to store 2 two different things. We need to store the pair, and we need to store the max number product we've gotten so far. Or we can just store the pair because the max is stored in it. See how there's a lot of different ways you can do this already. Yes. So the pair will store the max technically by storing the two numbers that have the largest match so far. So for each pair, first multiply the pair together, compare product of pair to, I'm gonna say this is max pair, to max pair's product. If greater than max pair's product, set max pair 0, max pair 1 to new elements. And then we repeat until that's done. Then of course we'll return the max pair. The output should be the largest product of adjacent elements. So, oh, we're only returning the largest product. Never mind that, we can do the original idea, sorry. I made it complicated for no reason. So we'll do a max product. Multiply the pair together, compare the product of the pair to max product. Set max product. I thought we had to return the pair. There we go. Easy. So now we just have to turn into code. So first, let's get our variable max product, and it's reasonable to say that it should be the lowest possible number it can be. So every programming language usually has a constant to determine the lowest possible number. So we're gonna look for that real quick. Integer min size Python. So you have max int, and the minimum value would be negative -1. And the reason for that is actually pretty interesting. If you look up what an integer is, like, it's the number when it's 4 bytes is between negative 2.1 billion and 2.1 billion. But if you look at the last number, there's an 8, and that's because there's one extra bit at the very end. So the negative number is one higher than the positive number. So if we know what the max number is positive, we can say the negative number is that -1. So I'm actually going to print that real quick so we can see that number, because it will probably show up here. No, we can't. Well, if you set to an empty list, what do you get compared to? You would have to check if the list is empty or not, wouldn't you? Do we import system? Oh, we do not. We do have math though. Math might have something. Is that another way we can do it? Yeah, we don't have a sys, so we can't do that. Ideally, we would do it this way. So let's do that then. Start with the max product of the lowest possible number integers can be. We'll put it in manually and go from there. But why? My question is, why a list? Does Python have null? There is no null, but there's none. Okay. So some languages, like higher level languages, have a... That's not what I wanted to say. Have like a null value, and that's usually a good way to do that. So, as a programmer, like trying to use a structure that you don't need the capabilities of, like if you're just using a list to store a number, there's probably a better way to do it. Okay, yeah, I mean that makes sense. So here's a better way. We're gonna use none. So I'm gonna store MaxProduct equals none. I want to make sure this works the way it's intended though. MaxProduct is none. Alright, so we got MaxProduct printed, none, and MaxProduct is none is true. So if I set this to like 5 or something, let's do another test, it becomes false. So we know that this method will work for us. So we'll start it as a none. It's good to know this, that Python has like a null type of thing. So, going off that, we're gonna make a loop. Yes. So a lot of times, like, conditions are just can be put anywhere. So I can do 5 is equal to 4 in here, and it will evaluate and then print the result. Like, yeah, you can just print like anything that gets evaluated, and the program will do it for you. Yeah. So for oh crud, we don't know how to do a for loop yet, so let's look it up. It's probably like for something in something. That's my guess. For loop, yes. So for I in range, so we'll do 0 to, is this inclusive? What is range? Where it stops. Number of integers to generate starting from 0, right? You know, if it's just sorting through the range, why not just use the input array? Can we get the length of it? I think it's called like size, right? Size array. -1. Oh wait, no, it has to loop through the whole list. Okay, that makes sense. Well, we'll just do a range then. Input array. Size of input array. That's what I'm looking. Test. Run. Size is not defined. Length? I remember looking at this yesterday. And test is not defined because it actually is not. They are right. Okay, so that's 0, 1, 2, 3, 4, 5. So that is what we're looking for. However, that did 6 tests, so we're gonna put a -1 there because we want the length of the array -1. That's how many tests we're doing. They made us compare the index every time, so it's shorter than the list length. Interesting. Oh. Time to learn Python the real way, even though it still sucks to do. So, for each pair, multiply the pairs together. So we're gonna do product equals input array I times input array I plus 1. Because we'll start at 0, right? So 0 and 1 will be multiplied, then 1 and 2, 3 and 4, and... Wait a second. 0, 1, 1, 2, 3, 4. I skipped numbers, sorry. But you get my point. It's gonna go through each one. And then we're gonna compare it. So, if product, or if max product is none, or okay, so basically we're gonna see if max product is none. If it is, then we know we can add it as the new max product. However, if it's not none, if it's filled with the value, then we're gonna go to the next thing. So or runs until it finds a condition that matches, and then it goes on. So it's not gonna do the second part unless the first part does not match. It's not gonna try the second condition, or max product is less than product. And if you really wanted to, you could do this, just to be safe. Kinda gives you a better idea of what's going on. This is already brand new. There you go. So, we'll set the new max product to product if we have a higher match. And then, move on. Once we're done, we return max product because it'll be equal to something. Now, let's make sure the input will always be guaranteed. Guaranteed constraints. The length of the array is going to be between 2 and 10, and the number will be between -1000 and 1000 every time. Good. So we don't have to worry about having like an empty input here. If we did, we'd have to do some error handling, but no problem. So we're gonna just run our tests, our sample tests. Looks like they all checked out. You can take a quick look. And let's put some outputs here just to, or not outputs. Let's talk a little bit about this now in detail, now that it's written. So we'll go through the loop a few times. Max product starts out as none when the program is run, and we have to loop through this list. I becomes the number we are currently at, and we're looking at the numbers 0 through, in this case we'll say 5. We'll say the input array was the sample we were given. Actually, we'll do this one. This one's easier. So it'll be 0 through 3 because we have a -1 there. And then we're gonna do product will be equal to, it'll be the first, so once we're in here, I is currently 0. We'll do input array 0 multiplied by input array 1. That's gonna be the first step of the loop. And in this case, those numbers are 1 and 2. So product will become 2 for this first loop. Then we check if max product is none. True. So we enter the loop. Max product will now be equal to product, which is 2. So max product is 2. Then we move on to the next step of the loop and repeat. So now, input array is still the same. Max product is 2. I is now 1. So since I is 1, we'll do 1 and 2. Element 2 and element 3. Or element 1 and element 2, which is the numbers 2 and 3, will make the product be 6. If max product is none, it's false, so now we do OR. We check the next step. Max product is less than product. In this case, max product is currently 2, and product is currently 6. So this is true. Max product is less than product. So we're now going to set the new max product to current product, which is 6. Then we move on to the next iteration. Max product is now 6. I is now 2. And thus we're looking at elements 2 and 3. This would actually be 2, sorry. There's 4 elements, so 0, 1, and 2 makes 3 elements. I just realized that's a typo. So the second element, or the second slot, is number 3, and the third slot is 0. So 3 times 0 becomes 0. MaxProduct.none, or is none, false. MaxProduct is less than product. Is 6 less than 0? No, it's not. In which case, we don't even enter the loop or change anything. Finally, MaxProduct is 6. Now we're just going to return that. It is not 0 through 3 because we did length minus 1. So in this case, length of input array is 4. Length of input array minus 1 is 3. So the range of numbers it produces is 0, 1, and 2. Range produces the results of the numbers inclusive or exclusive. So providing a range of 5 gives you 0 through 4, which is 5 elements, but the 0 is what does it. It's still 3 elements though, element 1, 2, and 3, but the array slots are 0, 1, and 2. So I'll submit this, passed every test. Here's our first program. You have any more questions about it? That one wasn't too bad. That was a nice intro to loops and conditions. I'll try to multiply. Right, it'll try to do another element outside, which doesn't exist. So yeah, we do minus 1 to constrain our products here, because we're doing 1 extra. That's why the first question I asked when I started was, how many times do we hit the loop? Because until we figured that out, we can't fill in this number. And then we have to figure out, using programming, how to calculate that number. So this is how you do it. Yeah, the concepts are there. But that's like the hard part of programming. Figuring out how to programmatically calculate everything. Alright, we're moving on to another problem now. So it's always trying to figure out how it's going to be computed. Shape area. Below we will define an n-interesting polygon. Your task is to find the area of a polygon for a given n. A 1 interesting polygon is a square with a side length of 1. An n-interesting polygon is obtained by taking the n minus 1 interesting polygon and appending 1 interesting polygons to its rim, side by side. Here are the examples. So every iteration, it adds 1 square on each of the sides of the squares. So, for n is 2, the output should be 5, that's the area. For 3, it should be 13. For 4, it's probably like 27 or something. Anyways, this is going to require a bit of math to figure out. So we need to figure out what the formula will be for these guys, so we can figure out how to write a program to calculate that for us. It's probably pretty, it's probably not too bad. But let's write a quick little math thing. So, n equals 2, and shape area of n is 5. Right? So when n is 2, this is equal to 5. So then we have another one, let's say m equals 3. Shape area of 3 is equal to 13. You're still trying to understand the second sentence? You mean to find the area of a polygon? For a given n? Well, first step is understanding the problem. If next paragraph. I mean, it shows you. So, what it's saying, ignore what it's saying here, and just say, every iteration, it adds a square to all 4 sides of the square. So, here, it added a square up, down, left, and right. Here, it's going to do that for every square here. So on this square, it's going to add one on the top, the right, and the left. On this square, it's going to add one on the top, right, and bottom, right, and left. It adds squares all around itself. That's what it's saying. So because it's a consistent like growth, there is a formula behind this that you can calculate in order to figure it out. At least there should be, because well, it's an interesting polygon. 50 more times. Does my explanation not make sense? Because what I'm saying is exactly what it's saying up here. Like, let's pretend each square is like an instance, right? Just an instance. You get the explanation and how it works. Okay. This case? So what are you trying to say? There's no harder case, so to speak. I would ignore the explanation, honestly, and focus on... So, a lot of times when you're given a program, the explanation is like fluff. What you're really looking for is what the inputs and outputs should be. I usually don't even read this stuff. I usually go down here and look at this stuff first. Because this actually tells you programmatically what you're going to be doing. When n is 2, the result should be 5. When n is 3, the result should be 13. This already tells me a lot more than this stuff up here. And it makes a lot more sense. And your output is the area of that interesting polygon. So, like, I want to say that you don't need to understand this. This part's not important. This is fluff. It's like a word problem in mathematics. You're not going to read the whole thing and try to understand all of it. You're going to take the important information and ignore the rest. So we have to figure out the mathematical formula behind this, first of all. So when n is 2, the result is 5. When n is 3, the result is 13. When n is 4, I don't know what the result's gonna be. I'd have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares are added. So it'd be 25. So in the first instance, 4 squares were added. In the second instance, 8 squares were added. And in the third instance, 12 squares were added. So if you notice, every iteration, it adds 4 more squares to the amount of squares that need to be added. So technically, n equals 5 should require us to add 16 squares to the area, which would give us a 41. At least that's what I assume by doing this. If I count real quick, just using these white squares on the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. So 16 squares are added on the next iteration. So every iteration adds 4 more squares to the amount of squares that get added. And that kind of makes sense because if you think about it, if you just grow everything out in a straight line, like let's say this top square, we just added 1 up here and just had it grow upwards, and this square to the right, you'll notice only the corners need to be filled in, and there are only 4 corners. So on the next iteration, there are 8 corners, and on here there are 12 corners. So that does make sense. So now we can make a little formula based on that. So programmatically wise, the squares added will be increased by 4 for each iteration. So we'll say n will be some number, right? And then squares added will be 4 times n. And then we need a running total. So this is going to be looped based on how many times we are, how many times we do it. So our input is n. Loop n times. We know how many times we have to loop. And we're going to need a total to keep track of how many squares there are. So at the start there's only 1. Actually, we can say the total is 0. We can even calculate 1. Just to be safe. So, squares added will be, well, on the first iteration though, it's only adding 1 square. So I guess we need an exception. But on every other iteration it adds 4 squares. So we can do an if statement actually, if we really want to satisfy the number 1 condition. If n is equal to 1, then total goes up by 1, right? Otherwise, squares added, total will be equal, or will be added, squares added. And squares added will be set to 4 times n. That's really all it is. That's like our loop. So once we figured out how it works, we're able to get our result that way. So now we just have to write it in there. For I in range n, that's how many times we have to loop. If n is equal to 1, add 1 to the total. You need to make a total variable. Starts at 0. Apparently n will never be less than 1, so we don't have to handle like negatives or anything weird like that. Else, total will be added to 4 times n. And then return total. That's pretty much it, I think. Expected output is 5. Wait. Oh. We have to do n minus 1. I didn't catch that. So when n is 2, this would be multiplied by 2, which is not right. We need it to multiply by 1 when n is 2. So, just a small tweak there. That's weird. It is still incorrect. So let's go ahead and print out the total for each iteration. Take a look at what's going on. First it's 4. So that doesn't sound correct. Oh wait, There's another error in the code. N starts at 0, not 1. So if N is 0, the first loop, then we just add 1 to the total. Otherwise, let's say N is 1, we're gonna add... Oh, that should work then. I think that's why I had weird results. Yeah, we had a kind of a misunderstanding here. So how does it get to 8? If N is 2, it should give us a range. This should be 0 and 1. Let's check and make sure we're understanding this correctly. Range is 0 to 2, which should be, can I print out the... Can't do that. Just prints it out as a range object. I want the list. But either way, we get 2 totals, so we know that it's going to do 0 and 1, or should do 0 and 1. Oh wait. That's supposed to be an I. We loop n times, but we use the value I in the loop. No, if it starts at 0, it should be 1. That 0 is the first loop. If n is 1, then we're gonna loop 1 time. So the first loop, once we enter the loop, is gonna be 0, which means we have to add 1 to the total. So I'm getting I and N confused. All these inside the loop should use I, because, yeah, we have an I there. That is what's representing our current oh, I changed it in the notepad, but not here. I is, what is actually changing each time we go through the loop. Yeah. So. But that's how you debug stuff. Like, you're gonna realize, hey, why am I getting the outputs I'm getting? Because of this, or because of that reason. Like, you can figure that out, but because you're outputting what is happening with each iteration. So in this case, looks like we're good now. So let's go ahead and run the full set. We are good. Now the funny part is, this formula, it says the formula has to be able to compute up to 10 to the 4th iterations of this. So, when I first looked at this problem, I tried something very weird. I thought of each of these squares as its own object, and then I made it so each one would grow out. Kind of like this, but I made them represent as individual objects. The problem with that solution is it's not scalable. When you get to 10 to the 4th power, when you're doing it like over 10,000 times, it's like, it's not ideal. So, figuring out a formula, especially when it's something consistent, is really important to improve efficiency. When you can solve a problem with just mathematics, it makes things easier for you. And that's why you have to know mathematics for programming, at least the basics of it. Because if you don't, it's gonna make your life very hard trying to implement some things. Scalable solutions, I guess you could say. Alright, we're gonna try to get one more here, because this is a good set of exercises, so we'll do one more. Radio RG got statues of different sizes as a present from Codemaster for his birthday. Each statue has a non-negative integer size. Since he likes to make things perfect, he wants to arrange them from smallest to largest, so each statue will be bigger than the previous one, exactly by 1. He may need additional statues to be able to accomplish that. Help him figure out the minimum number of additional statues that are required. So, we're getting a list of statue sizes, and we need to figure out the minimum number of statues that need to be added. So we're figuring out how many statues are going to exist that don't exist already. So let's first talk about this problem right here. We'll use this as an example. We first look at statue number 1. Or first off, we rearrange the statues so they're in order. 2, 3, 6, 8. Right? Then we say, okay, well, we are missing some sizes here. The program should be able to determine that we are missing size 4, 5, we have 6, and 7. Yes, we will be doing sorting here. So once we sort it out, we just need to loop through our current set, compare it to the next element, and say, huh, is the difference 1 or is it greater than 1? If it's greater than 1, we have to add in extra elements. So we'll start by doing a list sort. We shouldn't have to do anything special because this isn't a paired list or a key list. So we should just be able to sort it without any other problems. Let's make sure this is a list first of all. It should be. It says the input is an array. Okay. Sort that real quick. Whoops. We don't want to print the result of that. We want to print the result of it. Does this sort it without... Okay. So it does modify it directly. So sometimes you have to set things after you call them. I mean, the speed at which you do it doesn't really matter. You're gonna get faster as you get more familiar with it. As you can see, I can come up with what needs to be done very quickly because I've done it for so long. So, that's expected. So, first step was to sort the array. And the next step is to loop. And we need to figure out how many times it's going to be the size of the array. Minus 1, because we only need... We're going to be comparing this to this, and we're going to be comparing this number to this number, and then this number to this number. However, we have something interesting going on here. If we just loop through, loop length of array minus 1 times. So it's a 4 size array, we'll loop 3 times. Compare I and I plus 1 values. If difference is greater than 1, then add I plus 1's number to the list. So here's how this is going to work. Compare I and I plus 1 values. Let's say we're looking at the first two numbers, 2 and 3, right? 3 minus 2 is not greater than 1, so we're fine there. But let's look at, let's say I was 1 instead. So we look at the first and the second slot values, 3 and 6. 6 minus 3 is greater than 1, so we'd enter this loop. We'd use i's value plus 1, and we'd add 4 to our element. First set I is 0. I is 0. I mean, it's gonna be in here. This is just pseudocode, but if you were to do it in Python, it'd be this. For I in range length array minus 1. So that's the code version. I was just doing pseudocode. So we'd add 4 to the list. After, or in between, I and I plus 1. So it'd be appended to this list. So we would say add I plus 1 to slot I plus 1. We want to call this append. Everything else moves over by 1 slot. Because we're increasing the size of the array, I would hope that this doesn't produce a static value, because if it does, then it's not going to loop the number of times we need. So we're going to do a quick test to make sure Python can handle this. So we'll start with the length of our array. How many times we would have to loop. This is what we're going to test to make sure this works. So 4 times. For I in range statues. So this should be 4 times. We're going to add an object to statues. Let's see if Python has an easy way to add to arrays. Add. We'll do list. List.append adds a single element to the end of the list. So I assume there's another version of it where we can list append, where we can actually append at a certain spot. It looks like there is. Do that. Where's the docs? So hard to find the docs. Okay. Adds an item to the end of the list. Oh, it's called insert. Inserts an item at a given position. The first argument is the index of the element to insert. By the way, I mentioned this tip in the previous video, but I highly recommend trying to stick to the docs. I would rarely ever go to a site like Stack Overflow or something, unless you really have no other options, because the docs give you the concrete information. This is exactly what it does. It doesn't have any context behind it, which is what you're looking for. You don't want context behind your learning. So this inserts it at the front of the list because that's spot 0 for item X. Okay, good. So that's probably what we're gonna use. So we're gonna do statues.append insert. We'll say insert at position 0. We'll just insert at the front, and we'll insert some random number. I'm gonna make it call it 1. What I want to do then is output the length of, or loop. I want to see how many times it loops. Technically, it should be infinite, but if it stops, then we know that we need to do something else here. Alright, so that's what I was afraid of. Just to confirm, we're inserting into our list. Alright. So this is what I was afraid of. This number is determined at the start of the loop. So when you append elements to it, guess what? It's not gonna count for that. It's gonna still just do the loop 4 times, even though we're adding more numbers to the list. And this will be a problem for us, because when we change the list, we have to loop through it. We have to start from that value and look at the next value, and so on and so forth. So, I do have a creative solution for this. You can update it at the end of the loop. Ooh, does it have that kind of functionality? Let's take a look. Update iterator? So this thing is just a list, effectively. So yeah, I was gonna resort to a while loop. Use a copy of the list. That's interesting. No, you can't increase the size of something by add. This is a function that returns the exact size of that structure. So you can't set that to something else. That's not a property. So you can copy a list. Let's try that. Instead of specifying any particular element, you just specify the whole list, like this. By the way, Python does have a really cool, okay. So, now this is iterating through every element. Interestingly enough, it's only doing the same thing as before. So even though we update it here, like, that's why we can't really use this, because this method, you update the array, but the array was defined here. This is a copy of the array. Can we just do this then? Why would we need a copy if we could have the direct reference, right? There we go. Okay. So this is what I wanted. Well, maybe. Because this would just keep going, right? Forever and ever, as shown here. However, the I is not changing, but that kind of makes sense. Like, trying to wrap my head around why it works like this. Oh, that's why it's happening. Okay, it's because I'm adding it to the beginning. Watch this. If I put it at the end. It does 6, 2, 3, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, forever and ever. So it was just dependent on where I inserted it. That makes more sense. So a for loop, if you just specify this, you do get them in order. Okay, that's exactly what we want, actually. Perfect. So instead of using this range thing, we'll just do for I in array. That's simple. I'm just trying to get my point across. It doesn't matter where we put it in. That fact does not matter. I was trying to prove a point here. The reason why I kept saying 6 was because I kept moving it over by 1, and the iterator kept going up by 1. So if we insert a number in front of what we're currently looking at, like let's say 6 was 0, so this would be I plus 1, we should see a 6, and then we'll see 1s from then on, if we're understanding this correctly. 6, 2, 3, wait, 6, 2. Oh yeah, I see, because I did I should be doing... Wait a second. This returns the direct value. So you would need another value to track the... Oh, that's why people use range. That makes sense. So you need another value to track the array position. You're lost? Well, this is... Honestly, you have to learn how to do this if you're gonna get into programming. This is what makes programming difficult. You need to be able to take your like learning and be able to experiment with it and figure out what how the things you have, the tools you have, actually work. This is why programming is difficult. So let me try to explain what the problem here. I'm currently printing out I, okay? This is I. The thing that says loop right now, I'm looking at it. And the reason why I'm looking at it is I need something that tells me which position I have to insert the next value into, right here, this part. When we are ready to add a number to our list, we need to say which slot we're adding it to. Well, when I look at this code, I notice the I value is not the slot number, it's just the value at that slot. Which is interesting that Python does it like that, because I would like to know retrieve iterator count. Is there anything else I'm missing here? Like, Python is weird in this sense. It's not that it doesn't update the indexes, it doesn't have indexes. That's what the weird part about these loops, these Python loops. When you're doing something like this, you're not telling it to figure out which indexes it is. You're literally saying for each value of that array, like say the array's like this, it's literally gonna make I equal to this, then equal to this, then equal to this, then this. It's not gonna know which position it's at. This is partly why I hate Python. Like this implementation doesn't make sense to me. So when you're doing range, length, getting the array, range returns a range like this, which essentially gives you the array indexes. So you think that I is storing the indexes. No, it's just storing numbers that happen to represent the indexes. And it just so happens that when you call them in that order, statues 0, statues 1, you get them in the correct order. It just happens to be that way. But if you were to supply an array with just like random numbers in it, like we're doing right now, you only have access to those numbers. There is no such thing as element 0 or the first count in this loop. the numbers are going to be 6, 3, 1, and 7 for I. It doesn't know where in that list it's at. That is what's confusing. So, we're going to make a loop counter. Loop counter starts at 0. Every time we go in here, loop counter goes up by 1. This lets us know which index we are actually at. So now we can confidently say I is loop counter, and that's actually what index we're on. I always forget that. How about we just sort it first? We're not writing the program yet. We're trying to test something, remember? We're still on this part. We're trying to figure it out. Like I'm writing this to test. Like, we're not writing the program right now. Pretend this says something else. You have to write the pseudocode before you can write real code. That's like a rule. If you don't do that, you're just gonna be writing code and then you're gonna get stuck. So we have to make sure we have all the pieces before we can write our code. So now that we know how to get the index, we're actually going to be able to insert stuff at the correct position. So we know how to insert, we know how to, but what if it could possibly work if the list is sorted? It doesn't, because the rule, that wouldn't make sense. Like, if you did something like this, and you did something like this, you're still gonna run into the issue of you don't know which array index you're starting at. Like, this isn't gonna tell us that number 5 needs to be inserted at position 3. It's not gonna tell us that. Could you explain what you just did with this loop counter? I'm getting the index of the thing it is checking for. Alright, I'll go through it again. So, our problem. You always have a problem you're trying to solve. We got to this step. And we said, okay, we figured out what number we have to add to our list. So here, we got 2 and 3 and we compared them. And then we compared 3 and 6 and we said, oops, that's too big. We need to add the number 4 inside our list. But where do we add it to? Our list currently looks like this, 2, 3, 6, 8. Python doesn't know where to add this list. We don't know where to add this list. It's not stored in, that information is not stored anywhere. Because for I in array, I is currently going to be equal to 3 at this point. 3 is not where we have to store it. We have to store it at slot number 2, in between positions 1 and 2. These are the actual positions in the array. We have to store it between positions 1 and 2, which means it's going to become position 2. I is not going to tell us where to put it. So, we have to figure that out. So, I was thinking, well, why doesn't Python store the array index? Well, it's because all this does is loops through every value. So I will be equal to 2, then it'll be equal to 3, then 6, then 8. Python doesn't care how many times you loop. We just put it at position 2. But how do you know that? How does the program know that? We know that by looking at the numbers right now, but what if the problem was different? Now I'm gonna give you this. Alright? Now tell the program to insert at position 2. It won't be correct anymore. Actually, that's a really bad example. Let me do a few more. There. Now you can't tell it to be at position 2, because that's going to be incorrect. Because now, if you tried to do it, I'm gonna change this number. This is a bad number to use. Let's use like 6, because using 1 is pretty bad. It doesn't help us in this scenario. Alright, let's look at this scenario. We're currently at array index number 2. Let me write out the numbers again. 0, 1, 2, 3, 4, 5. Those are our array indexes. We're currently at 8, and we check and we realize we have to add the number 9 to a position. We technically have to add it to position 3 in the array. But I is equal to 8 right now. What is equal to 3? Nothing. That is our problem. We don't know how to identify that. So, that's why I created a loop counter. Because that's the only way we're going to be able to track which index the loop is currently at. Why don't we just, when I is 8, so index 2, just tell the program to add 9 to index 2 plus 1. Tell the program to add 9 to index 2 plus 1. When I is 8, index 2, we don't know it's index 2. Where's the number 2 in this scenario? Tell me. What in our program stores the number 2 right now? I need to get this clear with you. We do. We don't. No, we don't. Length of the list. Alright, length of this list right here, up there, is equal to 6. That's not 2. I still don't know where the number 2 is. Tell me where you see this number 2. Nothing in our program knows what index it's at. Also, this 5 should be somewhere. I think I meant to put 15, but whatever. That doesn't change anything. It starts sorting from index 0. Comparing from index 0. No, it starts comparing from number 6. This is what I'm trying to get at. The for loop takes a list of values and sets it to I. I will be equal to 6, then 7, then 8, then 10, then 15, then 16. It doesn't know the index. It doesn't care about the index. It just goes through the list. Python will see 6. No, it doesn't. Tell me how to get that. How do we get that? It doesn't know that. It actually doesn't. Because that's not how the for loop works. All you have to do, if that's true, just tell me where's the index stored. Because right now, I don't believe you. And this is one of my biggest gripes with Python. But if you know, please tell me. trying to remember. So you're telling me if I look it up, I'll be able to find it. Get loop index Python. Using an additional state variable, such as an index variable, is considered non-Pythonic. Use the built-in function enumerate. Returns an enumerate object. Iterable must be a sequence. Oh, so now we have to get... So we basically have to get a list. Oh, that's great. That's basically the same thing. That's retarded. Wonderful. So, in other words, the alternative to adding another variable. So this is my version of it. This is the way I would do it because it's easy to understand, in my opinion. I signed up for the battle in case I get chosen. It looks like there is an alternative that does it by storing it as a list. So, here's what this is saying. If we use what's called enumerate, we can store a second value somewhere and access that. So I will be, let's print out I here, and then we'll also print out what X is. That way. So I is 0, X is 6, I is 1, X is 1, I is 2, X is 1. Okay. So, looks like there is a Python alternative to this. That's retarded. I'm gonna be upfront and honest, that is pretty retarded. This is why I hate Python, dude, so much. That triggers me. Alright. You remember it being simpler. I can't think of something similar. It's either use a variable or use apparently this enumeration list that exists. But hey, either of those works. The point I was trying to make was I was trying to explain my thinking process since we were confused as to why I was using that loop counter. Get the min value of array and max value of array, determine difference, subtract length of array. Get min, what? Get min value of array, max, we don't care about this, we're talking about something else right now. We know how to solve the problem. We're learning how to change the enumeration of the loop when we're looping. So, that's what we were figuring out. It's solved now, luckily. So now we know how to append this number to this slot. So we got that part done. And that's pretty much it. The loop will take care of the rest. So we'll go through a step-by-step of it actually walking through. But when it's done, we need to return the minimum number of statues we added. So, interestingly enough, we don't have to actually store the number of statues. We really just have to store the number of statues we're adding. Let's see what this is. This is a while loop, buddy. While loops are a whole different thing. But Python's for loops are retarded. For loops have a completely different purpose than while loops. While loops are easier to implement and understand, but for loops are usually more powerful in that regard. Right, but the reason that works is because the indexes are defined. In a while loop, you're just like going up and down with the indexes. You're controlling that. In a for loop, it's like, for Python, for is like select the items in the list. That's what for loops are to Python. In other languages, it's more like something that, it's like a counter built in. A built-in counter that has a condition and then an iterator. So, I guess we could talk about that real quick. It's kind of interesting. So for loop in other languages usually have what to do first. So usually you're like setting a variable in there. And then conditions for loop. The loop will keep running as long as this condition is true. And then iteration steps. What happens after each loop? So a for loop immediately runs what to do first. The first section right away. And then the loop begins. Loop as long as conditions for loop is true. After each loop, run the iteration steps. That is what a for loop looks like in most languages. In Python, for some reason, a for loop is using this set of values, list, so for I in list, we're gonna say, using this set of values, set I to that list value. Look at how different these two are. It requires a very different mindset. Yes, that's what I was trying to say this whole time, Respect. Yes, very, very different. Now it makes more sense, doesn't it? So why don't we just use a while loop here? I mean, that's what I said. A while loop is a good idea here as well. There are so many ways you can do this. Okay, how about this? This may help you. Let me ask you, which method do you want to see done? Because there's like 500 ways we can do this problem. In fact, actually, I could show you multiple if you really care that much. There's a lot of ways to do this problem. That's what's great about programming. We talk about one way, and another way, and another way, and they're all valid. Now, obviously, some ways are better than others, speed-wise, but they're all still valid attempts. Which implementation would you like to see? We'll design a solution based on what implementation. Do you want to see a while loop? Do you want to see a for loop? Do you want to see the version where we don't add to an array instead of adding it to it? So right now we're like appending to the array, right? But I realized that the solution doesn't require us to append it to the array. So there is another unique solution we can do. Okay. Let's do it with the while loop then. So for the while loop version, instead of this, we're gonna say, so we're gonna have an array size, right? And we're gonna store like our loop counter, or we'll say I in this case. We'll start at 0. So while I is less than the length of the array, our list. That's really the biggest change we have to make right there. That changes the type of loop it is. And then the I will be used as the counter for this array. I mean, that's why the while loop is nice, right? Like the counter, it's self-explanatory, it's like built in. It's like a for loop in any other traditional language, pretty much. Length array -1. Yeah, we don't want to compare the last one, do we? That will overflow. Either way, Everything else remains the same. Now, here's the part we can change. Does this part kind of make sense to you? Why we don't have to do this? We don't have to actually adjust the array. So originally I thought we did, but the output requires us to tell them the minimal number of statues that need to be added. So guess what? There is a better way to compute that. If, for example, we're trying to figure out, hey, how many statues do we have to add to this list? All we have to do is for every element, if it's greater than 1, this is not greater than 1, so add 0. We just add to a running total. Is this greater than 1? Yes. So we add to our running total of 2 extra statues. 6 minus 3 plus 1. Or minus 1, excuse me. Gives us 2. See how that works? 8 minus 6, or 8 and 6, it's greater than 1. 8 minus 6 minus 1 is 1 extra statue there. So instead of adding to a list, and then determining how many statues difference we have, we could also just compare the number of statues we're adding between every list set. And that would simplify things, wouldn't it? It's still nice to know about this appending thing, though. It might come in handy in the future. Yes. So, that is an alternative to this, so I made a comment thing there. Because we could do this instead. So we have... we can delete this. If difference is greater than 1, we'll have a running total. Statues added. Started at 0. So if difference is greater than 1, add I plus 1 minus I minus 1 to statues added. In this case, that would be, for our example, 6 minus 3 minus 1 equals 2. So when there's a gap of 3, you get 2 statues. I'm still signing up for battles in case there's a battle, but which is correct. That means there's 2 statues in between. Then, we just return how many statues we added. So yes, this is a much simpler solution. Obviously our other solution could have worked, but again, it would have been more complicated, right? So with the while loop there, that should be our pseudocode. Now we just have to make it work. So, first step, we do have to sort the array, of course. Statues.sort. We'll define our 2 variables. We're gonna have a loop counter, that's I. I'm actually gonna label it loop counter / index counter. And then we have our statues added. Number of statues we need to buy, I guess you could say. Ellipses, yes. That's definitely what I wanted to type. Alright. So then we initiate our while loop while I is less than the length of our array, minus 1. Let's make sure this is implemented correctly. I don't want to go through and then realize I did it wrong. So 0, 0, 0, 0, 0, okay. We forgot to add 1. So once we're done, add 1 to I. That's why I wanted to double check, because we might have forgotten something silly like that. Cool. 0, 1, 2, 0, 0, 1, so on and so forth. Alright. So first step, compare I and I plus 1 values. If the difference is greater than 1, so we'll just do the comparison directly here. So we're comparing I plus 1 to I. So if the difference is greater than 1, statues added will be increased by the difference minus 1. Like so. When we're done with the loop, we'll return statues added. Unsupported operand types. Oh. How about we actually, you know, tell it which array it's getting the values from? So we can see here, it gave out 3 statues. It says 2 extra, 0 extra, so on and so forth. Let's do a quick sample loop here, just to go through it. Make sure our logic is sound. I starts at 0, statues added starts at 0. We'll use a sample problem here. 5, 4, 6, that's a pretty good one. Actually, this is a pretty good one. You understood this one? Good. Yeah, just for the sake of clarity here, what's going on? So while 0 is less than the length of our list, which is going to be 1, if statues I is 0, so 0 plus 1 minus statues 0 is greater than 1, where if we substitute these values would be 3 minus 0 is greater than 1, true. So we enter the loop. Statues added is increased by statues 0 plus 1. Where'd this come from? Minus statues 0 minus 1. Which ends up being, again, 3 minus 0 minus 1. 2 statues added. Now this isn't really looped, but that is pretty much how it works when you substitute the values. Sorry, 2. 2. You can kind of see why I wanted to do like a live talk, if possible though, when doing this. Because then when you ask questions, I can say, alright, this is the part you're not understanding, let me make it clear for you. Because that's the important part. We talked about it more and we said, okay, this is why it's working like this. This is why the for loop works this way. This is why this solution is easier and this solution is more complicated, etc., etc. Yes, the list has to be sorted. And it does get sorted at the top. We sort it at the beginning. If you don't sort it, what happens is you don't get the numbers you need. You actually get weird values if it's not sorted. Want to see what happens when we don't sort it? Yes, we do sort it. You want to see what happens when we don't sort it though? It's pretty fun. Unless you can figure it out. I'm pretty sure you could just figure it out. It actually doesn't give an error. It gives the wrong number. Oh, it definitely adds statues. While 0 is less than 3, right? Or 2, excuse me, we subtract 1. Well, no, we do it backwards though. We do the next element over minus the previous element. So 4 minus 5, right, would be -1. And then we would check that. Okay, -1 is not greater than 1. That's fine. And then we do 6 minus 4. 6 minus 4 is greater than 1, so it'll be a 2. So we do 6 minus 4, which is 2 minus 1. It would add 1 statue that way. Which is incorrect. We're adding 0 statues there. Yeah. So it does have to be sorted. We are under the assumption it is sorted. Oh, this is the OG? I'll listen to it. I've never heard it before, so I'll listen to it. playlist? This is actually through Spotify. And sometimes it picks a new song. I have all the Bandori stuff liked, and then sometimes it gives me other stuff. Mostly like idol-based songs, as you might expect. Some of them you have to find by their like Japanese names, so I actually found some by accident later on. No, I didn't want to do that. Oh god, it's like Bandori, we're listening to it again, no! That is not what I wanted. New song? Oh my god. I think I like the Bandori version better, but I am biased 100%. It's because it's sung by Pastel Palettes, that's why. Like, I don't particularly like the singers for this band. So there is one song I do like from them though. Let me go find it real fast, because I heard it and I really liked it, but I think it's the only song I really like from them. Sorry, I'm trying to look. It was played quite a long time ago. Might not be in here, dang. Okay, let me go look for it real quick. Should be in here though. I mean, I could share with you the Spotify playlist, right? Like, I could just share it to you, but it is on Spotify. God, where is it? This one? No. Sorry, I can't read Japanese, so I don't know what I'm looking for here. Alright, well, we got Pico. I swore I added it to my thing. Huh. Alright, let me do a quick little search. I might be able to find it that way. How do I see my, like, liked songs or whatever? Because I'm pretty sure I added it. Share screen? Oh, yeah. Okay, I guess we're done with that for now. You'll be my translator. Well, I don't see it, so I don't think it's even... Alright. So I was looking through here, but I'm like, okay, I don't see it anywhere. Because I'm pretty sure it would be in English, like it's K-On! So I should be able to find it based on that, but I don't see it. So I have a feeling this doesn't have liked songs. I don't know what it's called. That's why I have to go find it. That's not what I wanted. Like, see, all their songs are in English, so, like, I should be able to find it, technically, maybe. Yeah. I think it is. Hold on. Is it? Maybe Spotify will play it for me again. Dude, I was so sad when I played this chart on Japan. It's such a good song, but the chart is garbage. They have to redo it. I'm very disappointed. If you have not played it yet, you might be disappointed too. I really don't like it. Very good song. It's terrible how they did it. Where's the... Did it just start over? Start over. Like, okay, there's like 2 modes, right? Shouldn't there be a mode where, like, I can see... Like, it usually... Okay. Not that. Maybe it'll suggest it to me again if I go far enough. Because it suggests it to me every once in a while. Not this one. Christmas vibes, yeah. Also, I get this group a lot. I kind of wanted to... What is this? And why do I keep getting it? What is this group? Iris is a Japanese voice acting singing female idol group formed in 2012 by Avex, consists of 6 members. I keep seeing them, so I'm wondering who they are. Apparently they have a lot of Prepara? Prism Paradise is a Japanese arcade game. Huh. There's also an anime. Pretty... whatever world. Interesting. Looking for it. I swear I hit, like, save it to my library. I don't know what this is. Now it's just gonna go through all these again. What do you mean, why'd you skip it? I don't have time for that. Hey, I got picked. Alright, we gotta do the battle. The category is Roselia covers. Roselia, oh crud, I have to restart my thing. Bushimo. Alright, Roselia covers. Let me think real quick. Roselia covers. I don't have many Roselia covers I like. Is it multi or versus? Oh, crap. 58150. 58150. Do I have a perfect lock on right now? I think I do. Crud. Let me switch that out. Maya is a perfect lock. Red fraction. The gate. Shoot. What do I want to pick? Soul's refrain. Why is it so quiet? Oh, I know why. Careful, it's about to get loud. A little bit. Not that much. What? DC. Rip the DC. Alright, they're making a new room. Battle. Okay. Alright, respect. Gotcha. See you then. I'll let you know what happens. Yes, thank you. Thank goodness.
ごいバッチリだね。
Well, GG.
ギターはね、事前のチューニングが大切なんだよ。ギターはずっと一人でギター弾いてたから、バンド。
Back to my favorite. Yes. Alien win. Wait, I'm using the wrong band. Hello? Alright, whatever.
期待には応えないとね。
Oh.
あった？ バッチリだね。楽しく演奏しましょう。ギター
Where's my Aya?
ピン
I'm back.
まやちゃんハッピーバー。
Aww.
みんな行くよ世界は恋に落ちている光の矢胸を刺す君を分かりたいんだよね。教えてあんた行くぞ。ミミに電話をお願いね。さあやかすみここ一緒に合わせよう。涙こぼれて忙しい感情を言葉にリンクするチューニング確かめいい感じ。話しかけるな。まだ先輩ばかりと呼ばれてかすみちゃんもキラキラしてるものがかすんで逃げて今日もリスタート。世界は恋に落ちている光の矢胸を刺す全部分かりたいんだよね。聞かせてたった1ミリが遠くて駆け抜けた日々に一緒に行こう。あれば忘れない忘れられない輝く1ページ。あら先輩かすみちゃんも一緒に楽しもう。かすみちゃんいい調子だよ。もっといっちゃいましょう。これもザリャクのおかげだよね。
Yay.
今日のライブは楽しく演奏。
Play one more. I want to move to the Korean version next. Play a little bit of that. But I also want to eat, so maybe I'll take a break and then come back. Battle of the Bands stuff will continue later tonight, or the next day.
一丁やったろうじゃん。 の努力のおかげだよね。やったー。
Operation Salad Speedrun has been a success. Nice. Welcome back. I'm gonna be jumping to the Korean version for a little while. Play on that because I'm gonna be playing Battle of the Bands for the rest of the night. So might as well get in the event stuff while I can.
武士もクラフトエッグバンドリガールズバンドパーティーシージャン落ち葉がひらひら落ちてくなってな。
Anything new I need to know about? Nope. Oh, you know what's funny? They call Maya the brain of pastel palettes. Pastel palettes brain. Daily gacha. Let's go. Bushido. Alright. Pretty normal day. I think I'm gonna purchase an upgrade real quick. Wait, which band am I running right now? Poppin' Party? Oh, I already bought all those. What? A normal day is a 3-star, yes. Definitely. Hey look, it's Aya. So we're running Power 4 right now. Level 5, level 5, level 3. I can't really understand, like, long phrases. Bits and pieces. Save the rest. $26.24. Good. 2 Ayas and a flip. Actually, can we start with... Yeah, why not? Quintuple smile. It only triggers the second sticker. Oh, yes. Wait. That's not necessarily true. I can tell you why. If you're actually curious. It's the way it's programmed. See this for an example. And then see... Wait, why does Flea keep working? Flea, stop! I know why the Flea keeps popping up, but I don't know why it's not working for the other sticker. Yeah, it's not second sticker, it's something else. I kinda know why. What highest priority? Maybe, dude. Time to play the title song. Yeah. It is pretty fog. Yep. I really like it. Although it took me a little while to realize this was the title screen song as well. I was like, oh, no wonder it sounds so familiar. Yeah. Hey. What should we play right now? Let's play. Yeah. I love this song, dude. What should we play? Shua Shua. Pretty much. It is pretty nice.
今日の演奏は完璧。
最高のライブにしようね。
Their name's invisible. They have no name.
シュワシュワ曇りの流れの足がそんぴらさんのなって流れの足がそんぴらさんのびたって甘くて苦くて目が回りそうです。7世を目指してパーティーは続きを世界中さあ
I would say
世界を笑
yes.
顔に
Neo Fantasy Online is in about a month. So I guess that's the big one, right? That's a pretty big one. There's also an Aya and Chisato event that's like 3 or 4 months away. I believe Neo Fantasy Online is a mission trial thing. It should be.
ライブめっちゃ大成功だ。そうだ。だんだん寒くなってきたし、そろそろ衣替えしよう。
Yeah. That's when mission trials were first introduced. What? You're talking about Korea. Korea's a month ahead of us. Japan had it way, way back. Yep, Japan's about a year ahead of us. Korea's about a month ahead of the worldwide version. So it's upcoming. Right now we're on the Fue event. Oh, the song. No, we're getting the Fue event way later. Next event is a Eve's event. We're about a month behind, so Korea's like 4 events ahead of us. Basically, when the Halloween event came out for us, the Christmas event came out for Korea. Yeah, I know, right? I mean, we're slated to get the Christmas event probably around late November. Because we'll have Eve's party, then we'll have Lisa's lyrics, and then we'll have the Christmas event. And then we Korea just got done with the YOLO event, so that's right after Christmas. Well, Afterglow event. Speaking of YOLO, I feel like playing that now. I do like that one a lot. Rip. I just wanted to play my song. Yo, the Ayas though. But yeah, there's like 3 major events that I really want to be involved with. Hopefully, yeah. Let me point out the other ones I want to be involved in. So they have a good spread too, so which is pretty good. You want your events to have good spread, otherwise you can't save up for them, right? So a lot of people are really excited about Neo Aspect as well, but if I go for Neo Aspect, I can't go for the event I really want to go for with Aya in it. So I'm definitely gonna go for Aya's event instead. It's their Luminous event, their Chapter 2 event. And then the other one I want to be involved in is... Right, where is it? They're actually kind of close to each other. They're only 10 events apart. Trick or Escape. Because obviously, Aya's featured in it. Along with Hina. Both are really adorable. But yeah, the Luminous event has both 4-star Aya and 4-star Chisato. And then the other like Halloween event kinda has 4-star Aya and 4-star Hina.
大盛り上がりの綿棒をスティックに持ち
Oh yeah? Yeah, I mean, pastel palettes events, man, gotta love them. Hey, YOLO!
最高の演奏見せてやるぜ
Yeah, I really like the luminous one too. That's like the big one. I'm definitely saving up for that one. 100% getting that. This is my jam, yeah. God, the drum rolls suck though. Doing drum rolls on the fastest song in the game is ridiculous. Oh yeah, this is currently the fastest song in the game, by the way.
サナとジュイワシ雲を見てると
Play one of these. Ooh, BOF is good too. Hey. Hey. We have an AAO party going on. Oh boy. You want to actually help your wrist? Yeah, that song's a killer. That's what makes that YOLO so ridiculous.
決まりの本気見せて。あや先輩キラキラしてます。すみちゃんお寝るよ。決まり。何の音楽しそう。あすみちゃんいい調子だよ。もっといっちゃいましょう。
That's my one and only 27 expert song I can FC.
会場全体が秋っていろんな洋服が着れるか。
It's really fun though. Yep. I can't FC any of the other 27s. Really? It's slow though. It's tricky but slow. I mean, heck, this song I would say is harder than this game. If I was being honest. Like, good luck FCing this song. This song's like right next to YOLO in terms of speed. It's pretty rough though. I will admit, okay, it is easier than a 27, but it's chaotic. Chaotic. Did you do it on expert? Nope. I was about to say, that would have been a pretty impressive FC, my IO friend. Did I? No, I didn't. I got 2 misses. What are you talking about? Not even close. Not even close, dude. We're miles away from FCing it. Hey look, the flare. It's back. Ooh, believe in my flare. Also, that flare's name is Romeo. Just need a lucky run. Yeah, just need some luck. Yeah. One foot. Alright, time to die. Oh, how cute. It all comes down to how I do on that single tap part, once I get to it. I either get like all bads or goods on it, or misses, or I get like all perfects, and then the run is completely fine. It really depends on that one part. No, because it's actually Lo Mio, not Lomio. Maybe it's a play on words. I don't know enough Korean to decide if that's a play on words or not. This part right here. Oh, I guess we're playing fine today. It's rough for me. I think my biggest issue is locking down on the rhythm. Like, cause once you have it, right, it's just streams of easy notes. But like, that initial lockdown determines like if you're gonna hit everything or if you're gonna like just miss everything. I think that's my biggest problem right now. I have to learn how to lock it down. We might hear more flare.
みんな盛り上がってる。最高のステージだね。私だって僕らは目指したシャングリラ。最高のステージだね。お願いします。十分をまとめ続けた今なら言えるだろう。ここが総楽園さ。まだまだ行くよ。さよなら青く日々よ。お願いします。いいねいいね。
Yes! All the fue. Haru skill tip. JK.
落ち葉がひらひら落ち
As if we hear this song, you know? No! Don't do this to me. Believe in my existence. Believe in my fue.
よろしくお願いします。
So cute.
どんなに遠く離れたって決して夢は終わらない。今だよ。緊張します。今です。乾いた風に指をかざして、イブちゃん素敵。ため息一つ飲み込んだ。言えない痛み、水への不安。努力は無駄にならない。僕はここから動けない。光と影の境界線で私も感動だよ。なくした夢を探すんだ。もう一度自分をあの場所に解き放て。明けない夜を数えながら泣いた日々をずっと忘れない。どんなに明日が遠くてもきっと僕らは負けない今。まだまだ止まらないよ。感動。あなたは反応したよ。僕らはファンだ。あやさん、イブちゃん、まだまだ止まらないよ。
Well, it's not picked because it's not the... It's the event song right now, so people would play it in the event thing, not actually pick it. Right? At least that's the idea.
最高のリズム。あ、
Crap, I did a circle selection. Hold on, I'm doing something real quick. There we go. Cute. Server settings. Oh.
今度みんなと。さあ行こう。
Oh, I survived the flicks. That person has the stamp quote as their name. Nah, gaja. Webcam. No. This is a recording. Pre-recorded footage of somebody's fingers. GIF. A Giphy GIF.
これも努力のおかげだよね。
So many particles, so many numbers. Yes, this is Bang Dream, Girls Band Party. It's a pretty cute little game, rhythm game. I started playing it about 2.5 months ago. It's been a lot of fun. I really like it. Something to pass the time. Oh, I love this one too. Obviously, if Aya sings it, you know? Silhouette would be pretty good too. No, that's what I didn't want. F.
何が起きるか楽しみね。
F. Press square to F. Oh, there's a flip. What is going on? What is he doing?
綿棒をスティック。
If you want, I could blind you. How would that sound? You want me blinded? Ooh, that would work too, actually. Lily lights flying left, right, and center, changing colors and speed. Always wanted to be blind. Yes.
よーし、頑張るぞ。
Hey look, Remy's and Aya's. Isn't that adorable? They have like the same eye color. It's eye-opening. Ha! Got him! Uh, yeah, no. They're not legal, by the way, in case you were wondering. Still wanna play this. What do you mean this game? I already played it twice. Stop. They picked it again. I'm telling you, dude, I played this game way too much. Have you seen my streaming numbers? Well, that's not the crazy part, Mumbo fan. The crazy part is that I have 2 accounts that are very high ranking. Oh, rip. Because this is the Korean version. I also have one on the international version. Hey, Heyday. They picked it for me. Yay. Yeah. Oh, now we get to play the song. So, this song's good. Oh, I could do 6 trillion years on this version too, but I don't know if I'm ready for that tonight. We could try it one time. I'm willing to give it a shot. I think you asked me that the last time I streamed. No, it wasn't Dragon Nest. We talked about this. So I was playing like Minecraft one day, and Mumbo fan came into my stream and he's like, "Why do I have you followed?" And I don't think we figured it out. I mean, I do programming, League of Legends. I like this song too, I'm gonna play it. All the Afterglow songs, man, they got some really fast ones. This one's fast too. This is like... hitting this drum roll is really difficult. Steady stream at like 200 something beats per minute. Proves atheists were wrong all along. You play an okay amount? Dude, I just love this game. Okay? Just understand that. Can I hit the drum roll? We'll see. Oh, I almost got it. May 4th. So that was right after I got done with like my Final Fantasy 14 spree. Yeah, that sounds like around the time I was programming. I was really big into my Minecraft server stuff. Wait, no, Final Fantasy 14 was this year. Last year was all Minecraft. Very, very hard on the Minecraft stuff. Ah, yes. What should we play? We need to play... Oh yeah, we're gonna try 6 trillion years. If I can find it fast enough. I don't remember what it's called. Rip. Oh. After this stream, I'll be dead, so, see you guys later. Love you all. After this song? After this song! Oh, I'm feeling it.
身に余る罰を受けた悲しいことは何もないけど夕焼け笑顔を届けよう手を引かれてさ知らない知らない僕は何も知らない叱られた後の優しさも雨あれありのせるぬくもりもねえほんとに寒いんだ知らない知らない僕は何も知らない夢の一つも見れないくせに誰も知らないおとぎ話は夕焼けの中で消えてた目に焼き付けてくれガロ
まだまだいくよ今だよキラキラしちゃうよ
Surprisingly, my thumbs don't really get sore. You know what does get sore? Whoa, was that 6? That was less than 30? Wow, that was 24 combo breaks. That was good. My thumbs don't really get sore. I stopped playing well before my thumbs get sore, believe it or not. Usually we get sore on my arms. That's what gets sore. It's partly because I'm holding a mobile phone the whole time while playing, and so my arms get tired before my thumbs ever do. So I usually stop playing because I can't keep my arms, like, steady after a while.
ちょままちょっと待ってちょっとほんとはちょっとは嬉しいけど次元ようぜよ強す好きなんかじゃない
Rip respect.
ちょっと待ってちょっとほんとはちょっとは嬉しいけど次元ようぜよ強す好きなんか
Oh god.
ババーンって感じでいこう
Take care, man. Thanks for stopping by. Good to hear from you again. You have a good night. No fun. I think I have a foil on this server too. Oh, I do. I have this one. That's the same one, right? Yeah, I have the same foot. I think this is where I tested the Fwed thing. I remember now. God dang. I didn't realize I had this many cards on this version. Initiate Fwed. We got Hina with the cookie. I did not get a cookie Hina yet. Sad. I didn't get a Sayo either. Like, this version has some cool stuff on it. And of course Hagumi as well. For a sequence activate.
イワシ雲を見てると秋になったことを実感するな。
Oh yeah? Nice. Kinda wish I got her. She's gonna be useful during the next Roselia event. Lisa's lyrics. That's the very first event I had on this server. What is Eve's home party gonna be? It's gonna be a powerful event? Aw, there's a 3-star Flay in there. That's cute. That's one of the event cards. I'm definitely getting that. Gacha has a Kasumi? Oh, this one. That's where that card's from. That one's nice. I'm kinda liking this, and I always like the pastel palettes events. I mean, hey, you got like 12 to 15 rolls for every event for the daily roll, so decent chance. Like, the odds are pretty good to get the 3-star. We're back here. Wait, how'd it go backwards? Whatever. Oh, that's because I did 6 trillion years, that's why.
闇の方が無限で太陽ばっか眩しくて闇の方が素敵イエーイ乗ってる
調子はどうだいブリンク
形ぬるぬる一丁と逃げれば
ひまりちゃん
楽しいね避けるぞ避けるぞいい調子だよね袋ヒヤヒヤそれでも好きです姿パヤパヤそれでは行きましょう高みには映らない
準備はいいかい
これはにしなくちゃほら消えちゃうでしょ太陽なんか眩しくって闇の方が無限です太陽なんか眩しく
任せてくれ
闇の方が
決まり
Never heard this song? It's a pretty adorable little song.
すごい私も頑張らなくちゃ
It's got the yeah. I think that's the first time I have seen this song though. Nice. It's kind of interesting. Oh, that's a nice way to exit the app. The song has a part where there's a slider and a flick on your other finger. So you can't actually, if you're used to like flicking or moving your other finger when trying to flick it, then that's usually where I miss a note in the song, because I accidentally flick with both fingers when you're only supposed to flick with one. Because you can't flick slider endings for some reason. If you try a flick, you just lose it. 'Otherwise, I think it really feels more like a 25 or a very low level 26 song. I don't think it's really a 26 other than the sliders with the flicks on the other finger. Because you have to release and flick at the same time. Cute and fun song though.
「
私たちの音ならいける。最高の演奏。それは
ポッピンパーティーの作曲は基本的 私も頑張らなくちゃ。
最高のだよいいよ。さあ練習練習。目指すのは頂点、ただ一つよ。
気分次第でストーカー敵を選んだ戦う少年がねたい未来もなくて夢に描かれるのを待ったそのくせ未来の不安を明日を嫌って過去に願ってもうどうしようもなくなった気分だ明日よあなたは来ないでよ僕を置いて月は沈み日は昇るけどその世は違ったんだ君は
Rip respect.
よし。
やったね、ホタイ。
Oh, don't. Okay.
スポーツの秋、読書の
I'll probably be taking a break pretty soon before the next day of Battle of the Band starts. So, I'll probably disappear for a little while. Gotta eat and prep.
よろしくお願いします。
Because we've been playing for, what, 6-7 hours? So, time for a good old break. Yeah, it's very late for you. Let's see where we're at. Hey, 2291. Probably go for 2000 for this event. I'm gonna try 2 again. Last time I tried 2, I got sniped.
秋の月ってなんだか神秘的。
What? What should we play? Let's play this. Or that. That works too. Cute song incoming. I want to play BOF and Days. And then I'll call it for now. Oh boy. Please! No! I'll just play them in free lives. This isn't gonna work.
Kira kiraの私たち、見てください。今
Heck yeah.
目いっぱい楽しもう。
二人分け合いたんださ夢集めて今立ち上がる We are one future 楽しいねそうやっちゃうともえ一緒にやろう OK さやリクセおなえ今日のさすごい負けてられない最高の演奏それはこっちいい演奏
Alright, last song. Days.
目いっぱい楽しもう。
Also a really nice song.
ともえ任せて。いい感じだなさやだね。ミミリ変わりゆく季節がしっかり決めなきゃ。街並み染めてゆく曖昧な時間が流れていっけー色の空ボーカル担当のあやだよ。いい感じだなさやだね。波が押し寄せる夢は遠くまでともえ一緒にやろう OK さやリクセ大切なものを見失ったあの日からした約束は砕けて散った激しく儚い記憶のかけらとどめ二人なら似た夢から覚めてもこの想い忘れはしないずっと追憶の日々が照らす今をいい感じだなさやだね。今しかないはーいボーカル担当のあやだよ。
Last song.
その調子まだまだ。最高のライブだった。よく私
Alright, guys. It's gonna be pretty much it for me for tonight. At least for a little while. In about 45 minutes, I will return to begin Battle of the Bands, the final day the finale. We've got more missions on the way, so for those of you that tuned in, thanks for watching. See you later, respect. Hopefully that programming stuff is going to help you out. I'll keep trying to do them when I get the chance, so stay tuned for that. Thanks for watching, everyone. What?